Hello everyone, welcome back to this video. In today's video, I'm going to show you how to download high quality river flood data from the European Commission's Joint Research Center, EC JRC. Whether you are a researcher, a GIS enthusiast, or just someone interested in flood risk, this dataset can be incredibly valuable. The dataset which I am going to show you how to download today comes from the European Commission's Joint Research Center. These maps are part of a global initiative to model flood hazards and provide critical data for disaster risk reduction. The dataset includes flood hazard maps for different return periods, like starting from 10, 20, 50, 75, 100, and 500 years return periods, representing the probability of flooding in any given year globally. Georeferenced, it also includes georeferenced raster files that detail the extent and depth of potential floods, and high resolution data that can be integrated into GIS tools for spatial analysis. This information is crucial for researchers, planners, and policymakers. It helps identify areas at risk of flooding, design effective mitigation strategies, and even prioritize emergency response plans. The dataset is publicly available and regularly updated, making it a really reliable resource for flood risk assessment worldwide. This dataset is particularly valuable because it includes modeled flood data for multiple return periods. These return periods represent the likelihood of a flood of a particular size occurring in any given year. For example, a 10-year return period indicates a flood that has a 10% chance of happening in any year, in other words, a flood extent or a depth of flood that could probably happen every 10 years. And for example, again, a 100-year return period corresponds to a 1% annual probability. Or in other words, we can say it is a flood depth that could probably happen every 100 years. So this is a very high depth of flooding. Similarly, the 500-year return period represents a rare extreme flood with only 0.2% chance of occurring annually. This is a kind of flood depth that could probably happen every 500 years. So this is really a very rare kind of flood depth that could probably happen every 500 years. In any ways, the flood depths that are estimated at different return periods are important for different applications, depending on how these flood depths could affect community, how they could affect infrastructure, how they could affect any development activities and life of people, livestock, and etc. So by analyzing these different scenarios, we can assess flood risk under varying probabilities probability of, like, just by considering the probability of these depths of floods that happen at different intervals of years, then this gives us the chance to assess flood risk under varying probabilities, and also identify critical areas for emergency preparedness. We can like identify at different return periods the most critical areas for intervention. So it is really important, and also evaluate long-term strategies for climate resilience and adaptation, particularly those the flood depths that could probably happen like every 100 years or 500 years, or even more than 50 years, could really be very important for a long-term strategies for climate resilience and adaptation. This comprehensive data set is essential for understanding flood dynamics and their impact across different time frames, and also making it a valuable tool for research, urban planning, and disaster management. Now, let me take you to this website where we can access the data from. This is the website of the European Commission. So in this website, there are important information available about the global river flood hazard maps. There are some descriptions about the flood data, so you can have you can read through and have some information about the data set. Then here we scroll down and let's click here, river flood hazard maps at European and global scale, and then here it is about river hazard, river flood hazards. Then when you scroll down, you will get two information here. One is about river flood hazard maps for Europe and the Mediterranean Basin region. This is only for Europe, and this river flood hazard maps for Europe and the Mediterranean Basin region is a gridded data set representing inundation along the river network for 9 different flood return periods. And similarly, the global river flood hazard maps are a grid data set representing inundation along the river network for 7 different flood return periods. They are similar, but this one is at global level, and this one is only for rivers in Europe and Mediterranean regions. Then we are interested in this. If you are interested in this one, then you can do that. And let me take you to the global flood hazard maps. We click here. There are similar descriptions that were available in the previous page. Then here are some important notes that you have to read through. Then we scroll. There are some important information in this side of the page. There are description, contact, contributors, and if you are interested to know who contributes, of course it is important, and how you have to cite this data set when you use it for report for different purposes, research or other kinds of studies. Then there are keywords, the data access, how the data can be accessed, and there are also publications related to the data set. So it's good to see these publications and know about the data set, how the data set was developed, and etc. Then geographic areas, and there are also additional information available about the data set. Then we scroll down. These are how we have to cite, and we arrive here about the data access, and we click here this link, and this link will take us to this page where a list of all the necessary documentations and the dataset are available. Here is a parent directory. There are information, but there is a README text file. You can read it and know about the dataset. Then the dataset that we are, the flood dataset, the raster dataset that we are interested in are available here at different return periods. RP represents return period 10, 20, 50, 75, 100, 200, and 500. So we can, if you click on any of these, for example, 10, then it gives you a list of flood raster data estimated at 10 years return period. This is global data. Then we go back, and you can also see the same for the 20 years return period. Then I think we can try the RIP 50. Then in RIP 50, we have this long list of dataset. ID, this is ID number 1, and ID number 1, this is north 80, west 170. So this one is a latitude and this one is longitude. And RP 50, this is a return period 50 years, and it is a depth data. Then this is a TIFF data that we have to download. And there is also reclass, another TIFF, which is not will not be just looking at this. Then you can also see here information about the size of the dataset and when these datasets probably are last modified, and the size as well as description. So here is when the date when these datasets were modified, and also their size is here. Size is 200 to 101K, 88K, 15 megabyte, 2.5 megabyte, and etc. So this is kilobyte and this is megabyte. Then you can have a look at the size of the dataset, because it is important to know about the size of the dataset, because it demands storage and memory of your computer. So you have to take into account the size of the dataset when you try to download. So let's take some examples. Just for your particular study area, you have to make sure that you have to search for the location of the study area that you are interested in, because the latitudes and the longitudes are available here. So it gives a range of latitudes and longitudes. Then for your study area, one dataset may be enough, or you may need to download multiple datasets to cover your study area. It depends on the size of the study area. So just make sure that just first you have to know the latitudinal range and longitudinal range of your study area, and then try to find those datasets within the given range of location range of your study area. So now let's take one example. Let's try this one. I'm looking at the size, but this is large. Maybe we can N60, then west W160, or we can try this one, 201K, and also 15 megabyte. Actually, that is large. Then let's go for this. Okay, this one, click on this, and then it will automatically download. Now it is downloaded here. Then we can visualize this in QGIS. Let's open QGIS. That takes a few seconds. Okay, let's go to the download data and drag it here. Well, now the raster dataset, the flood dataset has come to QGIS. Zoom to layer, sorry. Then we can visualize it like this. But let's go symbology, then single band. Yeah, and some depths may not be important if most of the time for flooding we may minimize the range of the values, but still this is okay. Then it is a flood data. I don't know where this place is. Where is the delta? Okay. This is, now we have to investigate what the data looks like. This is really very important. Then this is the extent of the data set. The data type is float 32, and the file size, the pixel size is very important here. I think this is nearly 30 meter by 30 meters data set. That is spatial resolution is 30 meters by 30 meters. Then here is a coordinate system and etc. Okay, this is one thing, but if your study area needs to cover a larger area than what we downloaded, then we have to make sure that we download all the available tiles for our that cover our study area. Then we can try this one. 23. It may take a moment because it is a larger data, 23 megabyte, but it seems that is okay. It will download very soon. Okay, it has finished downloading, and then we bring it to QGIS, and yeah, see, these areas are in the same areas. Okay. Then for visualization purpose, you can give the same range. For example, this is maximum of 6, and we can also go for maximum of 6 for this. Yeah. Now these are different tiles, but we have to merge them. To merge these data sets, we have to make sure that they are of the same type, as I have explained earlier. Then this is float 32, and the resolution is the same. And this is also float 32, and the resolution is the same. Then make sure also that they have the same spatial projection. Actually, before we dive deeper into using the data set, just merging, let's talk a bit about the types of data we are working with. When you open, just as we open the raster data, you might notice terms like this one float, that like what I said, this one, and or integer or whatever, like int16 or uint8 or something like that. That talks about the data type. For example, in this case, the float 32 represents decimal values with a high degree of precision, commonly used for continuous data like flood depths, temperatures, or elevation models, because they are data sets with decimal places, and they are ideal for data sets where exact decimal values are crucial for analysis. The int16, for example, 16-bit integer, stores whole numbers within a specific range. They're often used for discrete data like classification maps or indices. And if you encounter uint8, which is 8-bit unsigned integer, then that can only store, this is a data set that can only store whole numbers, but in a smaller range, which is common for simple data sets like binary maps, like flooded versus non-flooded areas. So it is important to understand what these data types are. The types of data impacts, because the types of the data set impacts file size and processing speed. For example, float 32 takes more storage than int16, but allows for more detailed analysis, which is essential for flood depth modeling. The EC JRC flood datasets, as you can see, typically use a format like float 32 to ensure high accuracy for hazard mapping. Then now next, let's merge the dataset so that we make sure that we have one raster data for the entire study area. Then we go to raster, miscellaneous, and then merge. It is straightforward, and we have these two datasets displayed in QGIS. We select them, and then we make sure that the data type is float 32. We have checked that, and make sure that it is similar to actually it comes by default, but if you have some other data sets then which are not in float 32, it may also, another option may also appear. As I explained earlier, you have the list of these different types of data. Different data types. Then input pixel values to treat as node data. Then this is really important. I should have told you. Let me go back. When we explore, we have to also see here down for node data. Now, node data in this data set are represented as negative 9999. So when we merge, we have to make sure that we give this value so that no data are not just visible in the raster when we visualize it. Okay, raster, miscellaneous. Let's go here, merge. Yeah, the two data sets. This float 32 input pixel values to treat this one. We paste 999, assign specific no data values to output. To treat as no data optional. Yeah, we can do that. Well, it's optional, but it doesn't matter if we okay, then next we don't have additional things to do. Then we save the merge one, and in downloads, let's go here. Merge. It will take a few seconds. I hope not minutes. Okay, now we can remove them. These are not important. Symbology and yeah, there might be some holes which exaggerate the range of the values. Then we may go up to 5. Then we can clearly see those areas that are fledged up to 4, 5, up to 5 meters depth of fledge. Yeah, that's it. I hope it was helpful. You now know how to download and start working with river flood data from the EC JRC. If you found this video helpful, please give it a thumbs up, share it with your friends, and don't forget to subscribe for more tutorials like this. If you have any questions or need help with GIS analysis, let me know in the comments below, on the comment section. Yeah, see you in the next video. Thanks a lot.